As you get further along in your math career, you start classifying and looking at numbers a different way. Well, you have natural numbers, you have whole numbers, integers, rational, irrational, real, and even imaginary. But for this particular video, we're going to hone in on two of them and determine the difference between the two of them, rational and irrational. So let's go ahead and get into the video. To be considered a rational number, you have to be able to take any number and make it into a fraction of two integers. And if you can't do that, it's considered irrational. So I have 8 examples here to show you, and then I have 8 problems that I want you to try on your own on a different sheet of paper. So let's go ahead and jump into number 1 and see if we can make 0 into a fraction of two integers. So to make 0 into a fraction without changing the value of it, you can simply put it over 1, right? So 0 divided by 1 is still going to give you 0 back. That doesn't change the value of it at all, and we've made it into a fraction of two integers. So 0 is considered a rational number. Now, if 0 was on the denominator, that would give you an error back. So as long as your fraction does not have a 0 in the denominator, then you're safe to consider it a rational number. Now let's go ahead and take a look at number 2. We should know the famous pi symbol. I always celebrate Pi Day on March 14th with my students. We always have a competition to see, well, how many digits can we memorize of pi? So pi goes on forever and ever and ever. It doesn't repeat, it doesn't terminate or stop at any point. It just goes on indefinitely. So the first few digits of it, we have 3.14159265535, and that's all I have managed to learn over the years. You know, I can remember more, as March comes around, just so I can show my students up a little bit. But the biggest thing that you need to know is that pi just goes on forever and ever and ever. At no point could you ever possibly make this into a fraction of two integers. So whenever you see pi, it is 1,000% always going to be irrational. You can never make that into a fraction of two integers. So I'm just going to say IR, or irrational, for number 2. And now let's go ahead and take a look at number 3. You're going to notice that this decimal stops after the 6. This is considered a terminating decimal because it stops or terminates after the hundredths place. I do have a video that talks about, well, how do we convert terminating decimals into fractions or mixed numbers? I'll link that in the description in case you want to know how to do it. But -1 and 86 hundredths as a mixed number is going to be -1. And since 86 goes to the hundredths place, this would be 86 over 100. We can simplify this a little bit. The numerator and denominator are both divisible by 2. So this would be -1 and 43/50. Now, if we technically want to meet the definition of rational, it would be a fraction of two integers. So I'm going to convert this now into an improper fraction. And you can do that by taking the denominator, which is 50, multiplying it by the number out front, and then adding the numerator. So 50 times 1 is 50, and then add 43. That's going to give us 93 in the numerator, 50 in the denominator, and a negative sign still out front. So this would be considered a rational number. So terminating decimals are always considered rational because you can make them into mixed numbers and then convert them to improper fractions to technically meet the definition of a rational number. Now let's go ahead and take a look at number 4, which is a non-perfect square of 76. Now, non-perfect squares, if you were to type in the square root of 76 on a calculator, it's going to give you a decimal that is non-repeating and non-terminating. Now, the square root of 76, if we were going to estimate this, well, it's between the two perfect squares of 64 and 81. So it's between 8 and 9. So if we had to estimate this, I would say it's 8.7 something. But I did jot it down on the side over here just to show you a little bit more digit-wise. So estimated, it's going to be 8.717797 ... And similar to pi, at no point can you ever make a non-perfect square into a fraction of two integers. So non-perfect squares are always going to be considered irrational once again. And now let's go ahead and take a look at number 5. We now have a repeating decimal. I also have a video that showcases how to convert repeating decimals into mixed numbers or fractions. So if you want to take a look at that video as well, I'll link that in the description. Repeating decimals you can convert into mixed numbers, and I'm going to show you that here. It does take up a decent amount of space, so I'm going to write it wherever, right? That way it doesn't run into my webcam or anything like that. So the very first thing I tell my students is we are going to take the number that's in front of the decimal point and completely ignore it for right now. And we're left with 0.24 with the 24 repeating. We know that because it just has that bar over both numbers. And what we have to do now is remove that repeating part so we can actually make it into a mixed number. And we do that by making two separate equations. The very first one is we're going to take x and let it equal whatever repeating decimal that we're working with. In this case, it's 0.24, and the 24 is just repeating forever and ever and ever. Now, since we have two numbers repeating, that's going to change what our second equation is going to look like. If there's one number repeating, you're going to multiply this equation by 10. If it's two numbers repeating, we're going to multiply both sides of the equation by 100. So x times 100 is 100x. And how do you multiply this repeating decimal by 100? You just move it two decimal place values to the right. So this would turn to 24.2424, and again, it goes on forever and ever and ever. Now that we have both of our equations, all we're going to do now is subtract them from each other. So we have 100x equals 24.2424 ... minus x equals, making sure that we line up the variables, the equal signs, the place value. So we have 0.2424 ... We'll draw our equal bar here. 100x minus x, well, that's going to give us 99x equals, well, 4 minus 4 goes away, 2 minus 2 goes away, 4 minus 4 goes away, 2 minus 2 goes away. And notice how that repeating block completely disappears, which is going to help us make a mixed number. And then 24 minus 0 gives us 24. Now to get x by itself, it's being multiplied by 99, so let's do the inverse and divide by 99 on both sides. And we're going to end up getting x equals, we don't want to forget the 13 that we removed at the very beginning, so this is going to be 13 and 24/99 as a mixed number. Now, once again, to meet the definition of rational, we want to make this into an improper fraction. So I'm going to get rid of all of this work and rewrite it up at the top here. That way, again, I don't run into my webcam. So let's go ahead and remove all of this. That way it's not in the way when we get to numbers 6, 7, and 8. So let's remove all of this, remove all of this. And now we have 13 and 24/99. So you can simplify this a little bit because they're both divisible by 3. So that's going to be 13 and 8/33. And then once again, we want to make this now into an improper fraction to technically meet the definition of rational. So we're going to do 33 times 13, and then we're going to add 8, which is ultimately going to end up giving us, I'm just going to write it over here, 437/33, which now deems it as technically rational. So again, if you want to check out the videos for repeating decimals and terminating decimals, again, I'll link that in the description for you guys. Now let's take a look at number 6. We have -7. Well, -7 we can make into a fraction by simply putting it over 1. So -7 over 1, well, -7 divided by 1 just gives you -7 back. So we would consider this rational. For number 7, we have 5/7. Well, 5/7 is already a fraction of two integers. All right, we're already done. It's rational. And then finally, number 8, we have the negative square root of 121. Well, the square root of 121 is a perfect square that's going to give us 11 back. We just want to make sure that we have the negative sign still. So that is going to be -11. And then if we want to make it into a fraction of two integers, we simply just put it over 1. So perfect squares are considered rational. So now I want to show you the 8 practice problems I want you to try out on your own. So make sure that you have a scratch piece of paper and let's get into it. Now it's time for the practice session. I want you to pause the video, try out all 8 questions and see if you can determine if they are rational or irrational numbers. And when you think you have all 8 ready to go, come back and play the video and see if you went 8 for 8. Now, if you're watching this part, I'm assuming you've tried out all 8 questions and you're ready to go over the answers. So let's go ahead and look at number 1. We have -19. Well, -19 can be made into a fraction of two integers by simply putting it over the value of 1. -19 over 1 just gives you -19 back. Well, this would be considered rational for the first one. So hopefully you're 1 for 1. And now let's go ahead and take a look at number 2. We have 3 pi. I instantaneously see pi and know it's irrational. So number 2 is 1000% irrational. There's no way you're going to be able to write that as a fraction of two integers. Now for number 3, we have 31. Well, 31 you can simply just put over the value of 1, similar to the first one, and it's still going to give you 31 back. So we have a fraction of two integers. Number 3 is rational. Now for number 4, if you went and watched the repeating decimal video and know how to convert these properly, I'm going to show you the work for it once again to determine if it's rational or irrational. So the very first thing that I do is I always ignore the number in front of the decimal point. So this -5, I'm just going to put to the side for now, and we're going to make our two equations. So we have x equals 0 point, and we just have one number repeating this time. So we're going to multiply both sides of our equation by 10 this time instead of 100. So this is 10x, and we're going to move the decimal point one place value to the right. So we're going to get 1.1 repeating, and then we will subtract our two equations. And I'm just going to do that down here similar to when we did the examples. So we have 10x equals 1.1 repeating, minus, line up your variable, the equal signs, the decimal points, the place values. So we have 0.111, and now we want to subtract our two equations here. So 10 minus 1 gives us 9x equals, all of our repeating ones are going to cancel just like we want. 1 minus 0 is 1, and then finally to get x by itself, do the inverse of multiplying by 9 and divide both sides by 9, and we're going to end up getting x equals -5 and 1/9. Now, again, if we wanted to technically meet the definition of rational, we're then going to turn it into an improper fraction. So we have 9 times 5, which is 45, and then add 1 up top, and we're going to get -46/9 for number 4, making this rational. So let's go ahead and get rid of all of this so it doesn't interfere later on. And we had -46/9, which would be considered rational. Now for number 5, we have the negative square root of 85, which is a non-perfect square. So this is going to be a decimal that just goes on. It doesn't repeat. It doesn't terminate. So it's non-repeating, non-terminating. So if we wanted to estimate this, it's between the two perfect squares of 9 and 10, 9 being the square root of 81, 10 being the square root of 100. So 85 is leaning closer to 81. So I would say it's closer like 9.2-ish instead of something like 9.8, which would be favoring closer to 100. So I wrote down just a further estimation of it. It would be 9.21954, and it just keeps going on and on. We just want to make sure that it's negative. Okay, regardless though, you cannot make this into a fraction of two integers. Again, non-perfect squares are considered irrational numbers. And now let's go ahead and take a look at number 6. This time around we have a perfect square of 16. Well, the square root of 16 gives us 4 back, and to make it into a fraction of two integers, we simply just put it over 1. So the perfect square of 16 gives us a rational final answer. Now for number 7, we have a terminating decimal. It stops after the thousands place at that 2. So we can go ahead and make this into a mixed number to start. So this is -7 out front. 312 is going to be our numerator. And our denominator, since it goes to the thousands place, is going to be 1,000 on the bottom. 312 and 1,000 are both divisible by 8. So we can go ahead and simplify this a little bit. We get -7 and 39 125ths. And then technically, to meet the definition of rational, we're going to go ahead and turn this into an improper fraction and make it into a fraction of two integers. So we're going to take our denominator, multiply it by the whole number out front, which is going to give us 875, and then add 39. So we're going to end up getting -914 as our numerator and 125 as our denominator, making this terminating decimal rational. And then finally, the very last one, well, it's already a fraction, making it instantaneously rational. So hopefully you went 8 for 8 in the practice session. I hope this video helped you out in determining the difference between rational and irrational values. If it did, please leave a like on the video, comment any other topics you'd like to see, and again, please make sure to subscribe, turn on that bell for post notifications, and we'll see you in the next video with some more mathematics. Thank you guys for taking the time to watch, and again, I hope it helped you guys out.